Got it. Okay, we're gonna finish 4.2. The last thing we have to really do is this, determining whether two fractions are equivalent. Hey, so first, I want to explain what it means to be equivalent fraction. And I'm sort of losing my voice. I don't know why. So if I stop for a little bit, get something to drink, it's because my voice is like going. Okay, equivalent fractions. What's equivalent fraction? So what's an equivalent fraction? Well, basically, it's a fraction that represents the same number. And I'll give you an example. I'll give you one that you can see right away. So 1/2. We all sort of kind of know what a half means. I can write a half in an infinite number of ways. And what do I mean by that? 1/2, I can write it as 2/4. Because if I reduce 2/4, that's a half. I can write it as 3/6. If I reduce or simplify 3/6, I also get 1/2. I can write it as 4/8 or 5/10. And I can keep going forever. But it's just a different way to write the same fraction, meaning it's a non-simplified form, basically. We can do this with any fraction, and that's just by multiplying. So for instance, if I have, let's see, let me do 8/9. And I want to write an equivalent fraction. I can multiply it by any number I want. Let's say 10. And I will get 80/90. So 8/9 and 80/90 are what we call equivalent fractions. Same fraction, except one of them is not in simplest form. Sometimes they're easy to tell when they're equivalent. Sometimes it is not, because I don't have to multiply by a whole number. I can multiply by, I don't know, a fraction. I can multiply by a decimal. So sometimes a little bit harder to tell when they're equivalent. I'm just giving you examples that you can see clearly they're all the same fraction, just written differently. Okay, so now, how do you tell? So let's do one example and then we're going to practice. So are these fractions equivalent? That's what you're going to be asked. Are these fractions equivalent? And I'm going to put two fractions down, which is sort of funny. Same one I just wrote. Hold on. Let's do. Are they equivalent fractions? What you're going to do is you're going to put them next to each other and see if you can make one the other this time. So if I look at 11, I'm going to ask myself, 11, can I get to 22 by multiplying? Well, I can multiply by 2. I know that equals 22. So if I multiply by 2, that means I got to multiply 2 in the denominator to be equivalent. So it's 24 times 2, 48. Yes, these are equivalent. So whatever you multiply to the numerator, you have to multiply the same number denominator to make sure they're equivalent. For most cases, I'm actually going to show you a cute little shortcut in a minute. But let's say the answer, say the original problem was 11 over 23, right? And whoops, sorry, yep. And 22 over 48 was what I wrote. Are those two equivalent? Are they equivalent? Are they equivalent? I would multiply this by 22, sorry. 2, I'm ahead of myself, by 2, and I get 22. But if I multiply 23 by 2, I do not get 48. That does not work. So that these two are not equivalent. All right, so that's only just my examples of practice. Let's practice. And I can also show you my little shortcut for the ones that aren't easy to tell. Okay, practice. I'm just going to put, are these equivalent? Actually, hold on. That one's a little bit for later. Hold on. Let's do, okay. Well, so 4 over 8 and 16 over 32. I could do two things. I could simplify them both, see if they're the same. But basically, here, let me just change my color so it sort of stands out. In my eyes, this is what I see. 4 times 4 is 16, right? So is 8 times 4 32? The answer is yeah. So yes, they're equivalent. Two. Four over 13 and 5 over 18. Are they equivalent? Well, this is the first one that we can't multiply. I can't multiply 4 by anything and get 5. I can't multiply 13 by anything to get 18. So how do I tell if they're equivalent? So this is how you tell. You're going to cross multiply. So I'm going to put it right here. 4, 13, 5 over 18. So when I mean cross multiply, I really mean like cross multiply. Hold on. I need more space. 4 over 13, 5 over 18. We are going to multiply across. Means I'm going to multiply 4 and 18. And then I'm going to multiply 5 and 13. I'm going to show you what we're going to do. So 18 times 4 is 32 and 4, 72. Now, what is 5 times 13? So 13 times 5 is 15, 65. Okay, what you're going to do is you're going to look at these two numbers. That will tell you if they're equivalent. Are they the same number? No, they are not equivalent. So you cross multiply, and the number on top of each of them should be the same to be equivalent. Now, this has nothing to do with this chapter, but since we're doing this, I want to tell you something. See how 72 is a bigger number? That means this fraction is also the bigger fraction. You can tell if you're ever asked to see if one fraction is bigger than the other, you can tell by cross multiplying. And we're going to do a whole bunch of these, so you'll get it in a minute. You can do this by cross multiplying, and the bigger number is going to be your bigger fraction. It's like my favorite way to figure out when a fraction is bigger, less or bigger. Okay, let's do another one. 10 over 14 and 20 over 26. Okay, so I'm gonna write them next to each other because I'm gonna cross multiply, meaning I'm going to, now, since I'm doing 10 and 26, my answer goes on top of the 10. Well, 10 times 26 is just 26 times 10, which is 260. I just add a 0. And then I'm going to cross multiply the 20 and the 14, and that number is going to go on top of the 20. So 20 times 14, 0, 8, 0, 0, 2. I get 280. Are they equivalent? No. Not equivalent. But I also know something, which again is not really part of this chapter. It might be coming up. I also know that this fraction is my bigger fraction. Just by doing the same thing. I know two things. I know number one, they don't represent the same number. Number two, I can tell you which one's bigger, which one's smaller now by doing cross multiplying like that. Four, let's try this one. 7 over 28 and 2 over 8. Okay, so I'm going to write them next to each other so I can have room. Okay, so I'm going to cross multiply. 7 times 8 is 56. I write it on top of the 7. And then I'm going to cross multiply this one. What is 28 times 2? 15. Oh, look at this, 56. Are they the same number? Yes, they are. They are equivalent. And because they're 56, they're equal to each other. That's why they're called equivalent. They represent the same number, just in a different form. And that's how you do equivalent fractions. So there's a little section of that in the homework, but that's how you do it. You either know you can multiply, like number one, you either know you can multiply both the top and the bottom by a number to get the other one, or you can cross multiply and just see which one, if they're the same number. And then if it's ever asked to you, you can also tell which one's bigger and which one's smaller. Okay, questions on that? It's like one of my favorite things to do. Give me a fraction. I can figure out if it's bigger or smaller. And if they're equal to each other, I love it. All right, one last thing. We can use equivalent fractions to sort of answer questions. So I'll make this number 5. And then this section will be done. There are, it's a word problem, 25 students in our class. There isn't, but I made it up. If 15 earn a B, what fraction of the class hold on, looks like it is at 15. If 15 earn a B, what fraction of the class earned a B? Because sometimes fractions can tell us a lot more than what, a lot of things versus just a fraction. It can tell us a lot. So if 15 people out of 25 are a B, how much is that? So 15 students out of 25. That's your part that we're talking about out of the whole. In order to answer this question, though, it has to be in simplest form. And this is not in simplest form because I can divide both of them by 5. Divide by 5. Divide by 5. I get 3 over 5. So 3/5 of the class will earn a B. And I always say, if it's a word problem, something with words, you finish it with words. Don't just put 3/5. 3/5 of the class will earn a B. And I know that it can't really be done with you're doing your online testing and online everything, but when you get in the classroom, your teacher's going to expect you to write a sentence or something with words. I know I do. When I take points off if someone doesn't. So make sure you always end a word problem with words. I had questions. All right, that section's done, and we are now on 4.3. So I'm gonna turn a page though to start 4.3. Get a new page. Now we start actually adding, subtracting, multiplying, and dividing our fractions. We start with multiplying and dividing. Hey guys, if your camera's off, make sure it's on or you get it marked absent. Thank you, thank you. I've been having to say that a lot to all my classes. All of a sudden, everybody thinks that they could just like chill and not be on the camera, but that means you're not here. It counts as being absent. I cannot hear anyone. If you're talking to me, I can't hear you. Why can't I hear you?
Can you hear me, Miss Garrett?
Why can't I hear
Ms.
you?
Garrett, can you
Okay,
hear
hold on a second.
Josh?
Let me check my Bluetooth. All right, can someone talk to me, see if I can hear you now?
Can you hear me? Can you hear me?
Nope. Nope. Okay, hold on a second. I got new
Can you hear me?
earbuds and I guess they're not working.
No, I guess her
So,
earbuds
hold
are
on.
not working, but she do hear us talking.
Let me go back to my other earbuds. Let me see. Let's see. Okay, now, don't talk to me now. See if I hear.
Can you hear me?
I hear you now.
All right, awesome.
Yeah, I had to get near.
Sorry, I'm a little bit late.
It's all right.
Our computer system up here at the hospital just crashed. So
Did it
I'm a little
really?
late, sorry.
That's fine. Computers. Ugh. All right, so if anybody knows this, feel free to message me, but all of a sudden, like this week, my my AirPods, one I can hear and one I can't at all. So I got like cheapo ones, and I guess it didn't work. But we'll see how we do. But I can hear you at least in one ear, so we're good. All right, anybody who asked me a question want to ask me now, please do. I just couldn't hear you, sorry. Okay, I'll go on. I can hear you now, so keep asking questions. Okay, thank you for letting me know too. 4.3, multiplying and dividing fractions. Now, I could say it's simple as multiplying the numerator, multiplying denominator. It can be, but it also can be, there's also shortcuts. So I'm gonna put basically, which means not all the time, but this is what it means. Basically, we will be multiplying the numerator and then the denominator and then simplify the result. You always have to be in simplest form. Answer must always be in simplest form. Okay, so we're going right to like practicing. And then I'm gonna put some things in there. I'm gonna show you some shortcuts, practice. Because sometimes it can be really big numbers you have to simplify, and who wants to do that? Nobody. Okay, so practice. We're gonna multiply. I'm just starting with multiplying, and then we'll add in some dividing in there in a minute. Okay, so multiplying. 3/7 times 5/11. I'm just multiplying my two fractions. I'm going to multiply my numerator. So 3 times 5 is 15. I'm going to multiply my denominator. 7 times 11 is 77. Then you want to think if you can simplify or not. And in this case, this is not, you cannot simplify. You can try dividing by 3, but it won't work. So that is my final answer. By the way, everything we talk about with multiplying fractions is going to come into play when we divide fractions. So you're going to do the whole thing over again. The only difference between multiplying and dividing fractions is one little tiny step. That's it. Two. 1/3 times 1/9. Now, I don't know, I haven't looked close enough, but they might in your math lab still be doing this with a little X sign. Remember, it means the same thing, but we're not going to use that anymore because we're in algebra. But if they do the little X sign, it means the same thing. All right, so multiply the numerator. 1 times 1 is 1. Multiply the denominator. 3 times 9 or 9 times 3 is 27. Of course, that's totally simplified. I can't simplify anything else. Three, 4/5 times 2/3. I'm going to multiply my numerator and then multiply my denominator. So 4 times 2 is 8. 5 times 3 is 15. Can I divide by anything? They're both not even. I can't divide 8 by 3 or 5. So nope. Done. And the last one I want to do before I add something else to this is this one. 1/2 times 19/20. I'm going to multiply the numerator. 1 times 19 is 19. 2 times 20 is 40. I cannot simplify. 19 is a prime number. I cannot divide anything but other than 1 and 19, and I can't divide 40 by 19. So that's done. So that's nice when you don't have to simplify. So let me show you one that we do have to simplify. Two-thirds times 6/9. How come we don't cross multiply? It's a really good question. We only cross multiply, well, on the last page to see if they were equivalent or not. We're actually not solving or multiplying. We're not multiplying them. Let me go back to the last page. I want to make sure you get this straight in your head too, because it's important. We were looking for equivalent fractions and we cross multiplied only to see if they're equivalent. We were not multiplying them. It's a technique to find if one is bigger than the other, or if they're equal to each other. It is not multiplying fractions. It's only testing to see if they're equivalent. This, what we're doing now, is actually multiplying fractions. And how you multiply fractions is you multiply across, not diagonal, across. But I'm going to show you something right now with this problem. Okay, so 2 times 6 is 12. 9 times 3 is 27. Now, okay, now it's different. I can simplify this. So I could divide both of them by 3, and you always have to simplify your fraction. If I divide by 3, I get 12 divided by 3 is 4. 27 divided by 3 is 9. And this is my simplified fraction. I would say probably a majority of the time, you're going to have to simplify your fractions. It's pretty rare if they don't come out non-simplified. I mean, simplified. Usually they come out non-simplified. Hey, now I want to show you a technique right from the beginning, because sometimes these numbers get really big and it's very hard to simplify, especially we're doing it by hand, right? So I'm going to do this again a very different way. 2/3 times 6/9. And I want to start with something small like this. All right, I'm going to do something called cross simplifying. Notice it's not cross multiply. Cross simplifying, and you can use this when you multiply or divide with fractions. You either like this or you won't like this. It doesn't matter. You don't have to use this. It might be too confusing, which is just ignore me then. Don't look at it, see if you like it. I'll do a few problems like it and then see if you like it or not. I know my students in Dev 2 and intermediate algebra all use this. So I know the teachers are all doing it and showing it. So they all use this. Actually, it's the only thing we do to cross simplify fractions when we multiply. Okay, so what does it mean to cross simplify? So I'm going to look at my 2 and my 9. See how they're across from each other? If we were going to cross multiply them to check for equivalency, we would multiply them. Can I simplify 2 and 9? Can I divide one or both of them at the same time? No. So I can't do anything here. But if I look at 3 and 6, the numbers across from each other, they are both, I can divide both of them by 3. So what we do is we do something like this. I know I can divide this by 3, it becomes 1. I know I can divide this by 3, it becomes 2. And what you just did is when you get your answer, you're going to get the simplest form. 2 times 2 is 4. 1 times 9 is 9. So cross simplifying is great for simplifying your fraction because the final answer, your final answer is going to be simplified. Is already simplified when you use cross simplifying. Again, it is not mandatory. It's just optional. Let's do some more because you won't understand it till you do a couple of them or see a couple of them. All right, so let's see. I want to do 12 over 15 times 45 over 24. Now think about this problem in particular. If I do 12 times 45, that's going to be a pretty big number. If I do 15 times 24, that's going to be another big number. And then I got to figure out how to simplify it. That's why cross simplify comes into play. So I'm going to show you how to cross simplify this. So if I go across at 15 and 45, if I look right here, I can divide both of them by 5, right? So 15 divided by 5 is 3. 45 divided by 5, actually I can divide by 15. I'm going back. I divide both by 15. 15 divided by 15 is 1. 15, so 15 and 15 is 30, and 15 more is 45. So that's 3. 3 15s make 45. Now let's look at the 12 and the 24. I can divide both of them by 12, but that becomes 1, and this becomes 2. And now when I multiply across, I look at my new numerator. 1 times 3 is 3. 1 times 2 is 2. And I would simplify that to be a mixed number. How many 2s are in 3? 1. How many left over? 1. 1 and 1/2. Oh, something I want to mention about your online work too, because you're getting to the point where you have to pay really, really, really close attention to what they're asking you, because your math lab likes to go back and forth. What do I mean? They might tell you for this one, enter the answer as a mixed number. And the next one, they're going to tell you enter your answer as a decimal. And the next one, they're going to say, enter your answer as an improper fraction. They could be one after the other. They're going to go back and forth. Once you learn this, they're going to go back and forth to every question. So let's say they ask me for a decimal. I put 1.5 in, I'm going to get it wrong. So even though it's the right answer, I didn't do what they asked me to do. So make sure you read the directions of how they want you to put the answer in. Because that will keep you, especially when it comes to the tests, make sure you read the directions on how they want you to enter that answer. They are really good by going back and forth, back and forth, back and forth, back and forth. So really read what they want. My other class, my Dev 2 class, got so many wrong because they didn't read the directions. It would say enter as a decimal, they would put a fraction, and they got a whole bunch wrong just because they weren't reading directions. So make sure you read directions. All right, let's move on. Okay, let's practice. Practice. Six sevenths times 7/8. Now, I could multiply cross. So if you don't like that cross simplifying, we can just do what we normally do. 7 times 6 is 42. Well, that's like 43, 42. 8 times 7 is 56. And now I definitely can divide them. They're both even. So minimally, I can divide by 2. Can I divide by more than 2? Yes, I can divide by 7. Okay, so 8 times 7 is 56. 7 times 6 is 42. Oh yeah, I wrote problem wrong. Okay, never mind. But then I can also divide now by 2. So I guess I could divide by 14 before. But that's all right. You don't have to decimify it one step. 3/4. Now, if you want to do it the cross simplifying way, just to show you, I would go like this. Okay, so I look at my cross this way. I'm not multiplying, I'm simplifying. They're both 7. I can divide both of them by 7 and they become 1. And then I look across this way. They're even. I can divide them by 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. And now I can multiply across. And I'll say 3 times 1 is 3. 1 times 4 is 4. And notice we get the same answer at the end. But doing it this way means it's already simplified if you do it right. I'm gonna do-
Do you have a certain way you would want us to do it for the test?
Whatever you want. It's really whatever you want. Here's I'm not going to actually do this problem, but I'm going to show you why cross simplifying is really important. Let's say I have 148 over 2000 times 1525 over 642. Do you really want to multiply that across and simplify? I mean, I'm doing to extreme. I'll go to extreme, but
No, I would not want to multiply because
no.
ain't no
No.
telling.
But that's why cross simplifying is here, because you can get really big numbers. And then how would you simplify that at the end? You'd multiply all that out. How would you know what to divide by? Versus if you do it with cross simplifying, you can do one part at a time and bring it down to something that's manageable. Now, you would never get that kind of problem. I'm just doing a big example. So
Well, you
try
want to
it.
think about what you would want to think about, like what number would go, like what 2 numbers will equal that number. But then again, look at all your other numbers and figure out what will also go into that number.
Exactly. Okay, so we'll do a couple more and let's see, and then we're going to add something. So now -4 over 27. Yes, we can have negatives times -3 over 8. Hey, number 1. look at the negatives. What's a negative times a negative? It's a positive, right? So you might want to take a little note. You can erase this after. Just remind yourself the answer is positive. It's always a good idea. Now I'm going to cross simplify. I'm going to go this way first. I have 3 and 27. Well, I know 9 times 3 is 27. I divide both of them by 3. So 3 divided by 3 is 1. 27 divided by 3 is 9. Now I'm going to go the other way. I'm going to go this way. 4 and 8. I can divide both of them by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And now I'm going to multiply across. And I know it's positive already. I've already put my little note. It's positive. So I know it's positive. 1 times 1 is 1. 9 times 2 is 18. And then you don't need to leave the positive. You can take it off. That was my little note to remind me it was positive. I have 1 over 18. Now doing this one by multiplying across, there is nothing wrong without not using cross simplifying, nothing. As long as you're okay with this. So I do the same thing. Negative times negative is positive. I leave myself a little tiny note. 4 times 3 is 12. 27 times 8. So what's 27 times 8? Let's see. 8 times 7 is 56. 8 times 2 is 16 plus 5 is 21. And then you would have to fool that a little bit and simplify it. So maybe I might divide by 2 first, because I'm not quite sure what they're divisible by. 6 over, okay, what's 216 divided by 2 is 1, 2, bring down the 1, which makes a 0, bring down the 6, which means 8, 16, 0, that's 108. Now I can divide by 2 again. That's 3 over, okay, 108 divided by 2 would be 5. We're going to 8, 54. And then I'd have to make sure, can I divide 3 into 54? I don't know. 1, 3, 24. Oh my gosh, I really can. 8. So now I can divide by 3. And I get 1 over 18. You see how that worked? That went into simplifying that fraction. Now, if you're lucky and you know right away that you can divide everything by 6, divided by 6. Or divided by, I think it was 12 actually. But see how that work that went into it versus cross simplifying, you get the answer out. But there's nothing wrong with it. There is nothing wrong with it. If you don't like cross simplifying, that is fine. All right, 3. Let's do 30 over 49 times 7 over 10. So what I want you guys to do, I want you guys to do it. You can do it any way you want, cross simplifying or multiplying across, whatever you want. At the end, get the simplest form of the answer. Okay, so how we do? I could multiply across, I'll do it both ways, depending on which way you did it. If I multiply across, I know 30 times 7. Well, 7 times 3 is 21 plus a 0, 210. And then 49 times 10 is going to be 490. And then I would have to start simplifying. I know I could divide both of them by 10, at least to start. 21 over 49. And then can I simplify any more? Yes, I can divide both of them by 7. That would be 3 over 7. And that should be your final answer. So if you did it that way, that would be your answer. I mean, the answer is the same either way, but that would be a way to do it. If you did cross simplifying, you would do something like this. If I look this way, I can divide both of them by 7. That becomes 7. Why is my thing so light here? 7. And that, hold on. I'm trying to fix my pen and I'm not even thinking. Okay, divide by 7 is 1. Divide this by 7 is 7. Then if I go this way, I can divide them both by 10. 3 divided by 10 is 30 divided by 10 is 3, and 10 divided by 10 is 1, and out will come my answer of 3 over 7. So it doesn't matter which way you did it, you get the same answer at the end. Questions?
I would say either way would work, Miss Garrett, as
Yeah,
long
so
as you come out with the right answer.
that's it. Whatever way you want to do it. Exactly. Exactly. It's just 2 different techniques, get the same answer at the end. Okay, so now I'm going to add a little bit of algebra to the mix. So let's say, and don't let it scare you because it's algebra. Okay, so I'm going to put negative 5x over 7 times. Now, parentheses also mean times, right? So now I'm going to put it with parentheses just to show you a different way too. 14 over 25y. We are still going to either multiply across and simplify, or we can cross simplify. I'm going to do it both ways. First, and very first thing I notice is I have a negative times a positive. I know my answer is a negative. I'm going to write it down so I don't forget it. So let's multiply across. I have 5x times 14. So 14 times 5 is 20, 70. So it is 70, and the x just comes with it. Because 5x times 14 is going to be 70x. And now I'm going to multiply my denominator. I have 25 times 7. 25 times 7 is 35. 7 2 is 14, 175. I have y. There's a y in the denominator. I just bring it over, multiply across, multiply across. So I have negative 70 over 170, sorry, negative 70x over 175y, but I know I can simplify because I can at least divide by 5 minimally. Can I divide more? Probably. I'm thinking it might be like 35 we can divide by, but let's just do a little piece at a time. Okay, so if I divide by 5, it doesn't affect the x and y. We're just dividing the number by 5. That would be negative. My negative is still there. I would have, see, 70 divided, I can't even talk. 70 divided by 5. 1, 5, 20 left. That's 14. 14x. 175 divided by 5 would be 3 is 15. With 25 left, that's going to be 5 over 35. And just like I thought, we can do more because we could have divided by 35, but that's all right. We can divide both of them by 7. And we will get a negative 2x. So 14 divided by 7 is 2 over 35 divided by 7, which is 5y. I forgot my y down here.
Oh man, the cross simplifying just literally made this so much faster.
Oh, much
I
much faster. I'm doing that next. Yeah, I'm just, not everyone likes cross simplifying, which is okay. It's not, it's all right if you don't like it. So I want to show both ways, but oh my gosh, cross simplifying so much faster, right? I love cross simplifying. And does it take you a little while to get used to it and get good at it? Yeah. So don't be too afraid to try it. Okay, so I'll show you how much faster it is. This is a perfect example. 14 over 25y. So let's say we do cross simplifying. So I look this way. 7 and 14, I can divide both of them by 7. 7 becomes 1, 14 divided by 7 is 2. Then I'm going to look this way. By the way, I usually don't write those little X marks. I'm just trying to show you, I want you to look at what I'm looking at. Whoops, sorry. You don't have to write those little X marks unless you want to. Okay, now I look at my 5 and my 25. And I need to make sure, I'm going to stop myself, that I put my negative here, but that's my answer has to be negative, and I don't want to forget it. So 5, I divide both of them by 5, that becomes 1, that becomes 5. And guess what? We're going to multiply across. So I have 1 times x is x times 2 is 2x. And 1 times 5 is 5 times y is 5y. And look how fast the answer came out. Isn't that crazy? Try cross simplifying is so pretty cool.
Yeah, I definitely prefer that.
Yeah, I love cross simplifying. But again, I know at the beginning, it's like, what? It just takes practice. Just takes practice, that's all. And I know you guys don't have a calculator, so that's why it's nice, because then you don't have big numbers to try to simplify. You can just simplify the little numbers before you multiply, which makes them little numbers, if that makes sense. Okay, so that's multiplying. We're going to come back to it when we divide, because dividing actually is multiplying, believe it or not. But we got to talk about something else. Okay, so now, first, we're going to find equivalent fractions in a little bit different way, but the same idea. First, I'm going to show you an example, and then we're going to practice a couple. Nine over 4x is equal to, I'm going to put a big box. That's we have to answer the box. The box we have to put an answer in, 36x. We had to figure out what goes in my box. How do you do that? Well, you're going to look at what you have. What I have is I have both my denominators. They both have an x, right? What's the only difference? Well, how do I get 4 to be 36? Well, that would be 9 times 4, right? Which means I had to have multiplied this by 9 to get 36x, which means I got to multiply this by 9, which means my equivalent fraction, that would have to be 81. So we're taking two fractions and we're figuring out what we multiplied by, and then we put that answer in whatever wherever the box is, put that way, wherever the empty spot is. All right, so practice. 1. Okay, so we're just finding out what goes in the box. All right, so 3x over 7 is equal to my box over 42. So I want to find equivalent fraction. So I look at what I have. What I have is my denominators. I have a 7 and a 42. So what do I multiply 7 by to get 42? And that would be 6. That means I have to multiply the numerator by 6. But what is 3x times 6? Well, 6 times 3 is 18 with an x, 18x. That would make that equivalent. So my answer in my box would be 18x. Two. 4 is equal to something over 6. I'm gonna make it small. What do you do when you don't have a fraction? It's a whole number. Remember, it really is over 1. Any whole number is over 1. Now I can see what to do. I have to multiply the denominator by 6 to get 6, which means I multiply the numerator by 6, which means 24 was my answer. So don't forget that every whole number is really over 1, and you can work that way. Three. 11x.
Here, do we
over-
leave it like that or do we simplify that?
No, you don't simplify it. You're just finding equivalent. So that's a good question. No, because they want you to, if you okay, let's put it this way. If you simplify it, what is the answer? 4, right back to where you started, right? So they just want to know the equivalent fraction. It's not going to be a simplified form. It's just going to be an equivalent fraction. It's a good question. But yeah, you'll be right back to where you started to. Yeah. Equals, we're going to put a box here. Let's see what I'm going to do. I'm going to do 22x. Okay, now this time I have my numerators. So how do I go from 11x to 22x? Oh, I had to multiply by 2, which means I'm going to multiply this by 2. And 24 times 2 is 48, but I have a y. So 48y. So just a different way of looking at equivalent fractions for a minute. It's just the same thing we just did. You multiply top, multiply the bottom. Doesn't matter, it has an X. It's the same kind of idea. Okay, so I'm going to switch my page. Any questions? I'm going to add a page. We're going to do some more variables. I'm going to show you this a little bit.
I do have a question.
Sure, go for it.
When we were simplifying our equations, or yeah, whatever, is there another way we can check our answers to make sure we're like doing them right?
Check your answers. I guess to go backwards and multiply whatever you divided by, or whatever you multiply by, to the opposite. So like, there's no way to really check your answers. Like, I guess we going backwards. That would be the way. So let's say, what do I want to say? 1/2 is equal to 4/8, right? How would I know if that's right? Well, I could go backwards and divide by 4. I multiplied by 4 to get that, right? I could, and this is a little tiny example, but you could divide by 4 and then see if that equaled 1/2, and then you'd be right. 4 divided by 4 is 1, 8 divided by 4 is 2. So that would be correct. So you can do the opposite operation to go backwards and check. Does that make sense? That's basically the only way you can really check, is actually go back and see if you can get the original answer by doing the opposite operation. I do want a new page though. And I think I'm going to change my order a little bit. I was going to do something first, but I think we'll go dividing first. Okay, dividing fraction.